Okay, good morning everyone. So since I have an unstable connection, so I will be giving you a pre-recorded audio discussing our lesson today. So we've already discussed the introductory of general chemistry, including the branches of chemistry. Aside from that, we also discussed the matter, the types of matter, and its classification. So now let's continue our discussion to atoms in periodic table. So let's start on defining atom. So every matter has a tiny particles. So that tiny particle is called atom. It is said that atom is a basic unit of an element that can enter into a chemical reaction. Yes, a single element is composed of a different atom. Okay, a single element. Again, a single element is composed of a many atoms. Aside from that, it is said that atom is made of even smaller particles, which are called subatomic particles. What are those subatomic particles? We have electrons, protons, neutrons. Subatomic particles also considered as the charges of an element. Okay, always remember that subatomic particles, aside from it is the smaller particles of an atom, it is also considered as a charges of an atom or charges of an element. Okay, proceeding. So as you can see in the illustration, we have the so-called orbitals. Okay, this is called orbitals, which is the outer shell of it is called electron shell. And with these electron shells or these orbitals composed of different subatomic particles that has a charges. Always remember that electrons is carries a negative charge. Next to electrons, we have proton. Proton is carries a positive charge, and neutron carries either positive or negative charge. When we say either, pwede siya mag-carry ng negative charges or pwede rin siya mag-carry ng positive charges. So always remember that electrons is negative charges, proton is positive charges, and neutrons is either positive or negative charges. So always remember that. Okay, continuing. Let's discuss first the first subatomic particles in an atom or in an element, which is electron. Electron is actually discovered by Joseph John Thomson, or we called him as J.J. Thomson. J.J. Thomson or Joseph John Thomson discovered electrons. It's said that electrons is a subatomic particles that possesses negative electrical charge. So as I've said, that always remember that electrons carries a negative charges. Aside from that, it said also that electrons is the smaller in terms of mass. Of course, because electrons carries negative charges. Actually, the actual charges of or the actual mass of electrons is 9.109 times 10 to the negative 28 grams. So that is the actual or the exact mass of an electron. And always remember that electron is the smallest in terms in mass. So literally comparing it to protons and neutrons, electrons has the smallest terms if we will discuss about the mass of it. So always remember that the exact mass of electron is 9.109 times 10 to the negative 28 gram. Okay, so the symbol of electrons is this small letter E with the negative sign. Always remember that. And electrons discovered by Joseph John Thomson, but the charge of electrons discovered by Robert Millikan. Remember the differences, huh? Electrons itself is discovered by Joseph John Thomson, J.J. Thomson, but the symbol of the electrons, which is negative, is discovered by Robert Millikan. Okay, what particular year? We have 9. So always remember that. Continuing our discussion, we have protons. So the next subatomic particles of an element is proton. It says that proton possess a positive electrical charges. That is actually right. Protons carries a positive charges. It said also that a chemist referred to the number of protons in the atomic number. So as you can see mamaya in our discussion, the atomic number is actually the number of the proton of an element. Okay. So atomic number is the same with the number of the proton of an element. We will be discuss that deeper later on. Proton is discovered by Eugene Goldstein. Eugene Goldstein. Always remember, proton discovered by Goldstein. Going back, electrons discovered by Joseph John Thomson, but the symbol of the electrons is discovered by Robert Millikan. Always remember that one. Okay, the actual mass of protons is 1.673 times 10 to the negative 24 grams. Always remember that one. And the symbol for proton is positive, a small letter P with the sign positive. Okay. Always remember the differences between electrons and the protons, ha? Regardless to the exact amount of mass of the electrons and the exact amount of mass of the protons. Okay. Continuing our discussion, we have neutrons. Neutrons, it said that it is possesses of no electrical charges, or either the charge of positive or the charge of negative. Always remember that one, that neutron is in the middle of between positive or negative charges. And the actual mass or the exact mass of neutron is 1.675 times 10 to the power of 24 gram, which has no sign at all, because as I've said, neutron is in the middle of proton, either positive charge or negative charge, which is electron. So the symbol of proton, we have N, small n, and a little bit this and this zero. This zero is actually defining that the neutrons has no charges, or it is in the middle. It is either the positive charge or the negative charge. Okay, continue our discussion. We have chemical symbol. So let's go now to the chemical symbol of an element. Okay, it said that chemical symbol is a shorthand method or notation of one or two letters representing a chemical element. Okay, as I've said, in a periodic table, we can see the names of the elements, but the most significant there is the symbol. As you can see, this element is a copper. So the symbol for a copper is Cu. As you can see, the number in this area, this is the atomic number of a copper, which is 29. And this one is the chemical symbol. And this one is the atomic mass. You can see that one in your periodic table. Okay, continuing. This is actually the exact illustration of a periodic table. You can see that one in your periodic table, ha? So I've already, your classmate already sent you a example of periodic table. So compare it to this, to my example. So this is actually a representation of a chemical symbol of an element. H is for hydrogen, helium, He is for helium, Li is for lithium, Be is for beryllium, B is for boron, and so on and so forth. And as you can see also that the atomic number, it has a list of atomic number, protons, and atomic mass. Always remember that protons is equivalent to the atomic mass or atomic number of an element. So the same lang. So if you have atomic, like for example in hydrogen, if you have an atomic number which is 1, the protons of it or the positive charge of it is also 1. Okay, continue. So let's take a look with this with a short history of chemical symbol. John Jacob Berzelius is the one who used the letters or symbols for elements. So it's said that according to John Jacob, there are significance of having a symbol. So it's said that that in having a symbol, it represents the name of an element. Yes, exactly. It represents the name of an element, one atom of an element, the amount of element equivalent to its atomic mass. That is actually correct. So that is the significance according to the discovery of John Jacob Berzelius. So always remember, always remember, guys, the persons or the scientists behind the discoveries of atoms and periodic tables. Okay? So, for the symbols of an element, we have John Jacob Berzelius. What year? Particular year? In the year of 1779 to 1848. Okay, continuing our discussion, let's go now on discussing the world of periodic table or the world of periodic law. Okay? So let's have a short history. So in 1869, Russian chemist, namely, remember this one because this is a very important person in the discovery of periodic table. We have Dmitri Mendeleev. Dmitri Mendeleev is a German chemist, including Julius Lothar Mayer, proposed the periodic law. Okay, so accompanied by Julius Lothar Mayer, Dmitri Mendeleev proposed the periodic law, which says that periodic law states that when elements are arranged in order of increasing atomic number, elements with similar chemical properties occur at periodic regularly. Okay, regularly reoccurring intervals. So that is actually the discovery of Dmitri Mendeleev, including or accompanied by Julius Lothar Mayer. They discovered the periodic law, which periodic law is the arrangement in order, klasa, in order of increasing atomic number each element. So always remember that one. Continuing our discussion, in accordance to periodic law, it so called as a periodic table. Periodic table, guys, is a visual representation of behavior described by the periodic law. Okay, the difference between the periodic table and periodic law is that periodic law is the arrangement in order of increasing atomic number of an element. Comparing it to periodic table only the visual. So the representation or the example that you have in your yung binigay ng classmate nyo is actually called as a periodic table because it is the visual. Yung makita na natin. But if we will be dealing on the in order or the arrangement of the increasing atomic number, that is so called periodic law. Okay? Going a little bit of history again. According to Dmitri Ivanovich Mendeleev, in the year of 1834 and 1907, he discovered the constructed of periodic table. Aside from Dmitri Mendeleev discovered the periodic law, of course, Dmitri Mendeleev also constructed the visual of the periodic law, which is called as periodic table. Okay, always remember that one, class. Okay, continuing our discussion, let's discuss now what is periodic table. Periodic table is a tabular arrangement of the elements in order of increasing atomic number such that elements having similar chemical properties are positioned in vertical columns. Okay, always remember that periodic table is a visual table, meaning it is actually discuss, that table will be show the periodic law, which is actually the periodic law is the increasing or the arrangement of the increasing of atomic number of a certain element. So always remember that periodic table is the visual of the periodic law. Okay. Next, or continuing with that, we have the visual of periodic table. As you can see, this is the shown or the illustration of the periodic table. So we can see now the group and the period, or we can see now the columns or the row, or we can see now the period, the horizontal or the vertical lines. So as you can see, periodic table is composed of atomic number, chemical symbol, chemical names, and also the atomic mass or weight. Okay, this is the illustration of periodic table. So take a look with your periodic table, guys. Compare it if it is the same. Okay, continuing our discussion. So let's now discuss, as I've said, the inside of the periodic table. As I've said a while ago, periodic table illustrate the group or the period, the vertical or the horizontal, and of course, the symbol, names, and weight of it. Okay, let's discuss first period. Period is an horizontal row of an element in the periodic table. It actually started with the Arabic numbers at the top of the table. So that is the period. Yung row. Okay, I will be giving you example that one in the next slide. Next one is the group. If period is a horizontal row, group is the vertical column. As I've said, we have horizontal and vertical. So this is the differences between the period and the group, okay? Group signifies the vertical column in the periodic table. It usually designated by using Roman numerals and the letters, which is A and B. So always remember that one. I will be giving the example in the next slide. Okay, next. So this is the example of the periodic periods and groups. Okay. Actually, periods is the horizontal. This is period. For example, that one, that line like that is period. Period is a horizontal row. Ganito sinusundan nyo itong kamay ko. That is period. And the vertical or group is like this. If that element is like this, it is vertical row or it is included in a group. Okay? Again, period is horizontal like this. Sundan po yung kamay ko, ganyan. Pahaba na patayo. Pag sabing vertical, we have ganito. Ganyan. That is vertical. The line straight, which is nakahiga yung line. Pag patayo, we have period. Pag pahiga, vertical. Okay, continuing our discussion. Okay, for the key term, as I've said, period, horizontal or row. Group, vertical or column. Let's have an example. Okay, check your understanding. Identify the element for the following. We have horizontal 4 and group number 4. So, let's try why the horizontal 4 is the potassium and the group number 4 is the titanium. Okay, let's take a look. Okay, it's said in this area that we will be looking the horizontal 4. So the horizontal 4 is the period. Okay, as I've said, you will be looking the period like this, pahaba. So, bilangin. We have hydrogen 1, 2, 3, and 4. So that is the horizontal 4, which is potassium. And in the same row of it, we have to count the column. We have 1, 2, 3, and 4. We have the titanium, the group number 4. Naintindihan? Paulit ko. The same with the line of it, the horizontal, bilang lang kayo ng 4. 1, 2, 3, 4. Then you've got the horizontal 4, which is potassium. Then, the same with the line of the row, pero pa-column lang siya or vertical, pababa. We have potassium, calcium, scandium, and the titanium itself. So, that is the column 4 or the vertical 4. Ulitin ko, horizontal ay pahaba, ito, pa-straight line, and the vertical is pahiga. Okay, so the horizontal 4 is potassium, and the vertical 4 is titanium. Okay, another example. Let's try this one. It said that identify the elements for the following. Vertical 10, period number 7. So don't yung wag nyong baka malito kayo with regards to period and horizontal. If I use period, that is actually an horizontal. If I use horizontal, that is actually a period. Okay, always remember that one. It said that the vertical 10 has no answer, which is the answer is DS. Meron na pala dito, DS. And the period number 7 is FR, francium. Let's take a look. Okay, let's go now on identifying the horizontal 7. Okay, as I've seen, this is the horizontal 7. We have hydrogen 1, lithium 2, cesium 3, potassium 4, rubidium 5, cesium 6, and francium 7. So this is the horizontal 7. Connecting to the horizontal, bilang lang kayo pa vertical para makuha nyo ang DS or the palladium. Okay, this one. Okay, this is the vertical 10 or the vertical 10 or the group 10. Okay, as I've said, this is the horizontal or the period 7. Bilang lang ng 10. 1, 2, 3, 4, 5, 6, 7, 8, and 10. Okay. 10. Again ha. Francium 1, 2, 3. Okay. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is the group 10 or the vertical 10. We have DS. Okay, always remember that one ha. Okay. Next slide. Okay, let's go. We have already done discussing the period and group. Always remember that period is an horizontal and row. Group is vertical and column. Okay? So, the same line lang din siya. Kung saan po nakatutok si horizontal, doon po din po kayo bibilang pa vertical. Like this one. Diba? This is an horizontal. It said in this question that we will be looking at the period number 7. Okay, period number 7, bilang po. Hydrogen 1, lithium 2, sodium 3, potassium 4, rubidium 5, cesium 6, and the francium 7. So, in that line, pa-vertical lang po bilang ng 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, this is your vertical 10. The element that is in vertical 10 is DS. Okay? Or the palladium. Okay? Always remember that one. Continuing our discussion, let's discuss now the alkali metals, the alkaline earth metals, and the halogen or the noble gases. Okay, let's now know what are those elements that is in alkali metals, in alkaline earth metals, and halogen and the noble gases. Okay, next slide. Okay, take a look with this one. Alkali metals is general name for any element in group 1A. You can see that one in your periodic table ha. The group 1A. So group 1A signify as the alkali metal. So the group 1A of the periodic table excluding the hydrogen. Why? Because hydrogen is not a group 1A. Always remember that one. Excluding, hindi natin siya isasali. So what are those elements that is in alkali metals? We have lithium, sodium, potassium, francium, rubidium, and cesium. So always remember the element that is particular in alkali metals. Okay? Next. Okay, if there is an alkali metals, of course, there is an alkaline earth metals. So alkaline earth metals is in the general name for any element in the group 2A. So, take a look with your periodic table, guys, ha? Okay. Group 2A of the periodic table is include in the which include an element which is beryllium, magnesium, calcium, strontium, barium, and radium. So that is an element that is actually included in alkaline earth metals. Alkaline earth metals in a group is in a group of 2A. Diyan ha, always remember that one. Next to that, we have halogens. So halogens is generally named for any element in group 7A. So, group 7A. Let's take a look with the periodic table. Okay, what are those group 7A? This one. So this line is the halogen. We have helium, neon, argon, krypton, xenon, radon, and oxygen. So I hope na nakasabay kayo. So this line here, itong pink dito, this is the halogen. The group, as you can see, no. This is the noble gases. I'm so sorry, ha. The helium, neon, and the argon is the noble gases. The halogen is this one. The group 7A, we have francium. We have fluorine. We have fluorine, chlorine, bromine, iodine, astatine, and TS or testaline. Okay, so that is the halogen. And the noble gases is this. Yang na pink dito. Itong pink na ito, that is the noble gases. We have helium, neon, argon, krypton, xenon, radon, and oxygen. Always remember that one. Okay? So, going back to our discussion, noble gases is the general name of an element in a group 8A of the periodic table. Okay, always remember that one, ha? Ito, ha? So, 18A. So, that is the group of noble gases. As I've said, this one, this line, the 17A, I'm sorry with that, with the numbering kanina, this one is the halogen. And this one, pababa na ito, is the noble gases. The pink one is the noble gases, and this one is the halogen. So, always remember that one, guys. Continuing our discussion, let's go now on the representation of an atom. Okay, atomic number is represented by the letter Z, or the symbol of atomic number is letter Z. It said that it is the number of the protons and the number of neutrons in the nucleus of an atom. So, Z is equals to Z, as you can see like this is the formula. Z is equals to the number of protons and equal to the number of electrons. So, that is atomic number. Okay, continue. Mass number has a symbol of A. It is the sum of the number of protons and the number of neutrons in the nucleus of an atom. Let's see. This is the formula. We have A is equals to the number of proton. Number of proton and plus the number of neutrons. Always remember with the formula of it, guys, ha? Comparing it to the atomic number. In atomic number, we have the number of protons is equal to the number of electrons. That is why I've said that if you have for example, in hydrogen has atomic number of 1. So if it is 1, the proton of it is the same with the atomic number, which is 1. 1 din po ang proton ninyo. So wag malito with that ha. Atomic number is equal to the number of proton and the number of electrons. Sorry. Continuing, like in the mass number naman, if you will be looking for the mass number of an element, you have to add the number of proton and the number of neutrons. Okay, the number and the identity of subatomic particle present in an atom can be calculated from its atomic and mass number in the following manner. We have number of proton is equals to atomic number. Sabi ko nga, 'di ba? Kapag ang atomic number ng isang element ay 1, let's say in an hydrogen, kasi sa hydrogen ang atomic number ng hydrogen ay 1. So ang atomic number ng proton niya ay 1 din, because the number of proton is equivalent of the number of atomic number of an element. The same with the atomic number of an electron. Atomic number of an electron is equivalent to the atomic number of an element. And the number of the neutron is equal to the mass number, subtract it to the atomic number. So that is how can you get the subatomic particles of an element, ha? Always remember that the number of proton is equivalent to the number of an element, and the number of electron is equivalent to the number of atomic number of element again, and the number of neutron is equal to the mass number of an element, subtracting it to the atomic number of an element. Okay, always remember that one. Next to that, of course, let's try a little bit of a assessment. So this assessment is to be passed later. Later ha, I will be giving you this assessment. Okay, you will be answering this one if you will be now if you mag-view na kayo sa video ko, sasagutin na natin yan. Okay? So, I will be giving you the answer later part. Okay? So that is the end of our discussion. So, yung next slide is actually the answer of this assessment. Pero since i-assessment ko siya ngayon sa inyo, mamaya i-check natin siya. Okay? So, thank you very much for listening for today. So, this is the first lesson that we have. Let's continue it to the second lesson. We have chemical bonding. But before that, let's end our first lesson with the atom. So, I hope you understand my discussion. Okay, bye. Class, thank you. And please prepare for your exam on next Sunday. Okay.